In this question, we're given a graph which gives the volume of water in litres in a container at time t seconds after water started to flow out of the container. Using the graph, we need to work out an estimate for the rates at which the water is flowing out of the container when t is equal to 12. And now the first thing that we can always say is that when we have a graph with time on the x-axis, the rate is always equal to the gradient of the graph. This graph is a curve, and so when we want to find the gradient of a curve, we need to draw a tangent. Because we need to find the rate at the point at which t is equal to 12, we can draw a tangent when t is equal to 12. Now t is equal to 12 right here. And so we can draw a tangent at this point. Now we've drawn our tangent in purple, but you can also see a blue triangle. Now, to find the gradient of a line, what do we need to do? We need to find the change in y divided by the change in x. Now when we have a line, it's always good to draw a triangle. We can use our triangle to do this. For the vertical length, we have 24 at the top and 13 at the bottom. And so the change in y values would be 24 take away 13. And we can do the same thing for the change in x. On the horizontal side of our triangle, we have 15.5 at the end and 5 at the beginning. And so the change in x would be equal to 15.5 take away 5. And so plugging this entire fraction into our calculator, we can see that the gradient is approximately equal to 1.047 ... which we can round to 1.0 to two significant figures. And so we've found that an estimate for the rate at which the water is flowing out of the container when t is equal to 12 is approximately 1.0 litres per second. Now this question is worth 3 marks. We get the first mark for drawing a tangent at t is equal to 12. We get the second mark for our process to find the gradient of this tangent by doing the change in y divided by the change in x. And we get the third and final mark for the correct answer, that the rate at which water is flowing out of the container when t is equal to 12 is approximately 1.0 litres per second, allowing us to get the full 3 marks needed in this question.